Okay, ready to start? Ready to start?
Yeah.
So your next class is Wednesday or Friday?
Friday.
Okay, make sure you do your problem. Problem for you is you haven't done your homework. That's the reason you are struggling.
Actually, I prefer Friday because then I have more questions to ask.
Yeah, you say so
back
only.
to back the next day.
You say so only the last capacitor you didn't have time to do also. Anyway, the last part of revision is you alone. I can only guide you. Okay, anything you want to ask about capacitance? If not, let's go to electric current.
No, so far no.
Hope you have tried some question.
At least 2 questions yearly.
Okay, for multiple choice, section A, at least 2 questions yearly. Right? And then popular is not conduction electricity, but 14.2 to 14.4. Okay, can roughly see that. Every year we'll have a question or two, at least 2 questions. Okay, all these things you need to remember. Okay, what's the answer for this one? Conduction electricity in metal is due to vibration of ions in the metal, drifting of free electron in metal, the high random speed of free electron in the metal, the collision between free electron and
Donkey.
How can it be donkey? Donkey prevent simply guess only you. Never study. Vibration also cause collision. More vibration, more collision. Right? It's the drifting of the free electron. Right? The drifting is the one that caused by electric field strength applied to the conductor. Right? V is the drift velocity. This is caused by the accelerating potential across the conductor. Okay, drift velocity of free electron in metal conductor is?
Richard, this class how many minutes?
Say again.
This class how many minutes?
Will take about 10 to 15 minutes. We have actually finished our 1 hour already. I'm just giving extra.
Okay.
Drift velocity of free electron in metal conductor is most probable speed of free electron in the conductor, the root mean square speed of free electron in the conductor, the mean velocity of free electron in the conductor, which is due to electric field, the mean velocity of free electron in the conductor, which is due to random motion. Yep.
C, the answer is C.
Yeah. It's the drift
Memorizing.
velocity of electron in conductor due to the electric field, not the random one. Random one is caused by external temperature, or you call thermal agitation. So that one is just always there. It will just go at random like air in the room. Okay, this one, the potential difference V is supplied across a uniform wire of length L and cross-sectional area A. The number of free electron per unit volume is N, and the resistivity of wire is rho. If E is the charge of electron, the drift velocity of free electron is
A. Because V goes to IR and then I you make it what? NAVE
go to
and
resistivity
then
formula.
PL over A and then you get the answer.
And then use your definition for resistance. Right? V is still there. Replace your R inside here. So it's rho L at the bottom, A at the top there. Then your I equals NEAV. Right? Combine these two equations.
Yep.
Okay. So cancel the A. Answer is A, okay? Number 4, drift velocity of free electron in copper wire is in the order of 10 to the power minus 10 meter per second. Yet the current flowing is a few ampere. Which statement explain the effect? We just did that in the quiz. Yep.
C.
Number of density is large. That's why you just need electric field strength to accelerate a little bit only. Doesn't have to travel a long distance. Right? Electron is scattered through all the wire because it's large. Then you need to accelerate a little bit, then the current will flow. Okay, good. C, can remember? Right, number 5. Which graph shows the variation of drift velocity of electron with I in the conductor?
Donkey, because E equals to IR.
Yeah, just use this formula. N is constant, E is constant, A is constant. Donkey, correct?
So as I increases, V increases.
Number 6, the drift velocity of electron in aluminium is 1.66 times 10 to the power minus 4 meter per second. The cross-sectional area of the wire is 5 times 10 to the power minus 6. Assuming aluminum wire is supplied with 1 free electron per aluminum atom, what is the current in the wire? Okay, we can see that this one they require to calculate the number of charge carrier. I've given you the formula just now in the quiz. Yep. What is the answer?
Answer is donkey.
Right? That formula, you need to remember your number of mole is number of atom or Avogadro's number, the mass divided by relative molecular mass, and then your mass is density times volume. And then you just rewrite these two formula, this one and that one there, rewrite that. Then you can remember the formula, go ahead. Number per unit volume is this formula, memorize it. Quite common, they use it in the exam. Memorize it rather than derive it. Cannot remember it, derive it. And put in your value to calculate number per unit volume. Okay, then this is the formula you need to remember. Put in your value. Okay, good, donkey. Okay.
Oh my God, not even worth to do this question in exam because not enough time.
That's why you need to remember this formula, not derive
Give me
it.
1 mark.
1 mark is also can come out in the structure question.
Oh yeah.
Right? Just come out, structure question, they give you more mark. That's why objective is a lot of memory work, not worth it. Can do it, cannot, try the structure. Right?
Yeah.
Structure also to ask you this type of question. I said you get more mark than that, that's all. Right? This is a formula you need to remember. Giving you the revision note. A uniform silicon wire of length 0.2 meter is connected to a battery of potential different 5 volt. The electron density and electrical resistivity of silicon is given. What is the drift velocity of charge carrier in the silicon wire? Yep. Memory work, that's all. Nothing much about that. Reason you are weak in all this is because you have not been doing homework. That's why you cannot do the calculation part. Yeah, manage to calculate.
Yeah, managed to calculate.
What's the answer?
Donkey.
Right? There's your resistivity formula. There's your current is V over R. Right? Replace the R, this one inside here. So rho over L is bottom, A at the top there. And I is NEAV. V is just your I, NEA. Right? Then your V equals to, you want to replace your I, that I there. I is this one, that's your I. Then your NEAV. A and A cancel off.
So, let me get this straight, sir. 1 minute. Sir?
Yeah.
Okay, I equals to VR become VA over PL, right?
I, that's your definition. I is VR.
Yes.
So
Yes.
R place it here.
Yes.
So you got rho over L at the bottom. A will go.
Correct.
There.
Yes.
Then,
And then you have I equals to NEAV. So what you equate it together, right?
then I take the V. I want to find V. I take NEA down.
Yes.
Then the current formula is there. That's a current formula. NEA. A and A cancel. So I got V rho NE times your L. That's all. And put in your value. Okay. Unless you can find a shorter way to do it. Unless you can memorize.
Okay, wait. I equals to VA over PL and then V equals to 1 over NEA. The V
And you come
calculation
to
part
ask,
you did, I don't
tell you
understand.
about resistivity, you just go to resistivity formula. And then definition of resistance, that's all. And then drift velocity, that's the equation. That's all.
1 minute, teacher. That means wait, isn't it I over NEA, not 1 over NEA?
This is the definition for resistance. You replace that resistance, that's all. V over I. And then your I is given by that. Replace that. That's all. That's all I'm doing. Then after that, calculate your V. Can do any way you like. But I'm using 3 equations, that's all.
No, I don't understand how teacher did BA over PL times 1 over NEA.
We have already gone so many times already. Right? That is your resistivity formula. Then your I is V over R. Definition of resistance. So that R, take it down. Replace that R. So it's rho over L. Then A becomes on top. That's all. Now my I is NEAV.
Yes.
So V, I take NEA down. That's all. Cross multiply. Then my I, which is this is my I. That's my I.
Okay. Now I understand.
I cancel my A there. That's all.
Okay, now I understand. Okay, thank you. I was confused just now a bit. Yeah, now I get it. Okay, can continue.
Right? This one is a bit tougher.
So how you analyze this, Ajay?
Conductor of cross-sectional area A, which decreases with Vx is shown in a diagram. This is like what you did in your Bernoulli's principle in your STPM. When the constant current, right, I is constant, remember, flows through the conductor, which graph shows the variation of J with X. So get the formula. Right? J is I over A. Right? Your A is, you are told that your I is constant. Sorry, there's something missing. Right? You are told I is constant. So you're just using this formula. Right? You want J over A. I is constant. As A decreases, J also increases. Right? And look at the picture. As A decreases, your J increases. So the best answer is just B. Sorry, donkey. Am I right? Yeah, as your distance increases, as your x increases, your a decreases. A decreases. So J increases. Then the best answer is donkey.
So distance increases means cross-sectional area
We are interested
decreases.
in distance decreases. Sorry, distance increases, area decreases. Right? So area
Area
decreases,
decreases.
your J
Yeah.
increases. So that's
Yeah,
the
correct.
answer,
No, J
donkey.
increases.
That's all. Okay.
Oh. Oh, okay.
Nothing
Okay.
much.
So it's all about formula only. Like here, you have to use the
Just you
formula.
applying your formula and then applying your knowledge. Look at the picture there. As your X increases, your A decreases. So if A decreases, what does this tell you? A decreases, your J increases. So that the best answer is just donkey. Okay.
Okay.
Potential difference is 12 volt. Is applied to a cable of length 5 cm. If the resistivity is that, what is the current density of the cable? Okay, just playing around, getting to use the formula, that's all. This one, yeah, weaker because you have not done homework. That's the problem. So you don't know how to play with the formula. So how are you going to calculate?
R equals to PL over A.
So what's the answer?
Boy.
Right? First step, you give you resistivity. Go to the resistivity formula because you are given length. Right? Same as what we have done earlier. R is V over I. Right? Equate these two. These two are R. So replace that R with V over I. That's what we do. Rho L over A, V over I. Then we want a current density. Current density is I over A. So take the I up, take the L down, take the rho down also. So that's what we get. Then put in your value. Right? Potential difference is 12. L is changed to meter. And then resistivity, that's your resistivity formula. And calculate it out. Okay.
Okay.
Or you can go to definition of your conductivity. Same thing. Conductivity also can use. And then your electric field strength is V over L. Right? That's the alternative formula. So many different way of calculating is okay, whichever is faster. Okay, one or two more. Which is true about current density? Yep.
C.
See, definition, that's all. Right? That's your Ohm's law. Alternative way of looking at Ohm's law. Right? R for ohmic conductor, your conductivity varies with temperature. Right? Or conductivity decreases. Oh, this one shouldn't. What is the answer for this one given you already? You can see quite popular this type of question. And calculate out if you haven't done that. Okay, one last one already. After this one, density of copper given, relative atomic mass is given. If the copper wire carries a current, if current density given, what is the drift velocity of electron in the wire? Okay, you have to calculate the number per unit volume. If you can memorize the formula, go ahead, use it. And then after that, go to the formula for current density. What's the answer?
Boy.
Right? You haven't? Question 6, go to refer to question 6, the formula, put it in there, calculate your N. Then your right, J is NEV, V is just J over NE. Put in your value and calculate out. Yeah. Okay, one last one. You haven't done it, go and look through there. Okay. There's the formula we derive in the lecture note there. J is NEV. Calculate your trip velocity. The answer is boy. Okay, this one, two wires made of different material have the same uniform current density. If both wires carry an equal amount of current, the wires can be deduced to have different material, same uniform current density. If both wires carry equal amount of current, the wires can be deduced to have right? They are different material. Yep. Ken,
Can.
what's the answer?
Boy.
Right? Your J, you are told different material, same uniform current density. Go to the formula, NEV. And then J is I over A. J is constant, same I, right? Same current. So same A. Right, boy, okay. Okay, let's go to one last one. This one. The variation of resistivity of material with temperature is shown in the graph below. The most likely material is
Boy.
okay, good. We will stop here. The rest you can try out yourself. We see you next Friday. Make sure you try the question. If not, you are going to be lost again. Anything else you want to ask?
Not
Before we
just
have
that so far.
finished already. Okay. Have a good weekend.
Thank you.